Hi guys, I'm live. How you guys doing? I think it's math lesson time. Sorry if that's boring or sounds boring, but the Chinese say that you can't learn without teaching and you can't teach without learning. When you learn, you teach, and when you teach, you learn. And I've been trying to teach you guys math, and I think I'm finally learning it. Hence, I'm teaching what I've learned. The cycle. I want to discuss Euler's formula with what I finally understand about math after all these years. Explain what I didn't understand before and explain what that is and explain it. So Euler's formula basically says that e to the I pi plus 1 equals 0. E to the I pi plus 1 equals 0. I want to talk about this and, and maybe derive some of it. I've kind of jokingly said the meaning of it is that the exponent of an imaginary circle can be added to something and still be nothing. Pi is circular because pi is a ratio of the circumference of a circle to its diameter. That's pi. 3.1415926 wait. 3.1415925 25 maybe 1415926 something like that. It's an irrational and transcendental constant. Never repeats, goes on forever. It's the ratio of a circle's circumference to its diameter. And 0 is the number that when you add 0 to something, it stays the same. X plus 0 equals X. It's called the additive identity. And plus it's a very powerful number because when divided by when a non-zero number is divided by 0, you get infinity, which makes it powerful. Plus it is actually 0 equals the limit as X equals, gosh, yeah, right. The limit, I can't even write. The limit as X approaches infinity, now I'm writing an 8. Infinity, that's still an 8. Approaches infinity of 1 over X. That's one way of writing 0. Limit as X approaches infinity of 1 over X. 1 over X as X approaches infinity is 0. So 0 is a cool, passionate, powerful number. And 1 is the multiplicative identity because any number X multiplied by 1 equals X. And X is a cool, 1's a cool number too. Cool number also. And then you have E and I. Now, where I have gone faulty in the past is I didn't really understand E. I never did until today. I thought about it in monetary terms, in terms of interest, in money. I didn't understand the economics enough to understand E. To understand E, you have to step into, at least for me, I had to step into the world of money, economics, to understand it so that I then can understand it when I apply it in mathematics. There is math to economics. In fact, I was supposed to do a paper on the stock market at Harvard College my junior year. I only finished half the paper, so I turned nothing in, blew off the paper, got an F. First F I'd gotten since 4th grade. Okay. Dipped my GPA just below the dean's list. 2.91 is what I graduated with because that F brought me under the dean's list overall. Okay. So what is E? What is E anyway? The value of it is actually E equals 2.718281828, and it goes on and on, but it doesn't repeat 1828 over and over again. That's just a coincidence. It's also an irrational, and it's an irrational and transcendental constant like pi, as is pi. But what is that? What is that number derived from? Let's just leave it up there for now. Why not? What does that number come from? What is it? Who cares? How can you get that number from anything? How can you get that number from reality? Well, start with the world of money. If I have $1, if I have a 100, if I have a 100% annual, I can't write, annual return. Let's suppose I do 100% annual return. What does that mean? Well, it means what it says. If you have $1 and you decide to compound that interest, that means take account of it and figure out what it is. You leave it in for a year. That means it's compounded yearly at 100% annual return rate. You get $1 plus $1 equals $2. That's the least amount that you can get from $1 invested with 100% annual interest. I mean, annual return. Interest is when you pay. Return is when they pay you. So yearly, I get $2. Okay, starting with $1 and 100% annual return. Let's say I do return every 6 months. So that's by twice a year. So I have $1. After half a year, 6 months, I get $1.50, because if 100% is a year, that's $1. Then half a year is 50 cents, and $1 plus 50 cents is $1.50. But then that's how much I get. So I get $1.50 after 6 months. But after the next 6 months, I get that $1.50 times 1.5, because that $1.50 is now becomes, through the next 6 months, this $1.50 times 1.5. It's as if this 1.5 is the dollar, and so you take that, then you add half of that to it, and that's taking that times 1.5. This plus half of this. And that is then $1 times 1.5 squared. Is that right? Let me think. Yeah, it is. Because you're multiplying 1.5 to get the $1.50, and then you're multiplying it by 1.5 again to get whatever you're going to get. And I think this value is like $2, and should I do it by hand? It's $1.50 plus $1.50. Oh no, $1.50. Times 1.5. So it's 150 plus 150 over 2. What's 150 over 2 is 75 cents. So then this is $2.25. So that's what you get with $1 with 100% return compounded twice a year. You get $2.25. Every year it's $2. Oh, but there's this number we're approaching, it seems like, doesn't it? We're approaching 2.7. Are we maybe? Well, let's keep going. And I won't do all the rigorous details because we could be here for a million years. But let's just get the gist of it. If I compound it every 4 months, then I would have, after 4 months, I would have the dollar would be, 4 months would be $1.33, $1.33. Because 4 months is a third of a year, and a third of $1 is 33 cents. So it's actually, and then, but that's how much you would have after 4 months. You would have you would have $1.33. Then for the next 4 months, you'd multiply this by 133 again, 1.33. And then for the final 3 months, you'd take this and multiply it by 1.33 again. So what I would have for the interest for compounded every 4 months is, for $1, I would have, the interest would be $1 times 1.33 cubed. Ah, that's getting interesting. But what this part is a division of a fraction of 1. It's dividing 1 by something. So what I really have in essence is 1, and I should know what that, this would be something, this number would be above 2.25, above $2.25, but less than E, $2.72. Would be less than E, but more than 2.25. I don't know what the exact number would be. But what you're doing is you're multiplying $1 times $1 plus the fraction of $1 in the amount of time you're compounding, which in a third of a year is 33 cents, but that's actually plus the $1 divided by, in this case, 3. So that gives you the 1 plus 1 plus 1/3, but it's compounded 3 times, so you get 1 plus 1/3 cubed, and that's the next number that's above 2 but less than E. Okay, that's interesting. And then this may seem boring, but if you can pick this up, you got something that took me like 40 some years to learn, even though I'm stupid maybe. Then if you compounded every 4 times a year, you would get, that would be in 3 months, you would get, if you compound every 3 months, that would give you $1.25 for your first installment after 3 months. But then for the next 3 months, you'd get that times another $1 times 1.25 again. And that's after 6 months. Then after 9 months, you get that divided by, multiplied by $1.25 again. And then after the year, you get that multiplied by 1.25 again. And that's going to be more than it was with compounding every 4 months, but less than E. And more than 2. Some number between 2.25 or whatever, something between, and 2.72 or 71828, whatever. But what's this? This is 1 times, what's $1 actually? I'll say 1 times 1 plus 1/4. Okay, it's $1 times 1 plus 1/4 is the 1.25, but it's compounded 4 times, so you get that to the 4th power or 4th power, and that's 1 plus 1/4 to the 4th power, and that's approaching this number E. So what happens if you take this? We're going to take a leap of faith here, a leap into faith, whatever is the correct way of putting it. It's actually leap into faith, but I'm not trying to be a theologian right now. What if I take a number E question mark? Like, is it E? We're just going to assume it might be E, and let's just see. Question mark E, does it equal? Equal. What we're going to do is we're going to take 1 plus 1 over n. That as n gets bigger, the 1 plus 1 over n is what you get after 1/n of a year. But then you're going to multiply that. You're going to take the nth power of that, because however much that is gets multiplied by that much in times to get to the end of the year. And then we're going to say the limit. Dude, I can't write, man. The limit as n approaches infinity. And I can't, let's do it infinity. Can I even do that? As limit as n approaches infinity of 1 plus 1 over n to the n. So the limit as n approaches infinity of 1 plus n 1 over n to the nth. In other words, as this gets smaller and smaller, maybe I compound it every second. After 1 second, I would have 1 plus 1 divided by however many seconds are in a year. And then that number to the power of however many seconds are in a year. Now I'll do a millisecond, a microsecond, a terasecond, not bigger stuff. Nanosecond, how about a billionth of a second? 1 plus 1 over a billion, that's after one nanosecond, and then times times however many nanoseconds there are in a year. There's a number for you. If there's a billion nanoseconds in a second, how many are there in a year? That's the number you'd be taking it to the power of. But the number you're taking the power of that only. You're taking that power of the number that's only 1 plus 1 over however many nanoseconds there are in a year. So that's very small. That's very close to 1, isn't it? 1 over very big number, but then to the power of that same big number. It's the most, if you could make that down to as small as you could possibly get, approaching 0, or as n approaches infinity. This approaches 0, but this approaches infinity because 1 over infinity approaches 0. Becomes almost 1, but then it's to the power of a number that's almost infinity. Guess what? It turns out that yes, I know it may seem like a boring video, but E equals the limit as n approaches infinity of 1 plus 1 over n to the nth. That's what E is. If you compound it close, less and less, more and more times per year, you eventually approach 2.1. You eventually would get $2.72 for your original investment of $1, as opposed to just $2 if you compound it every year, 2.25 if you compound it every 6 months, and so on. You finally, if you compounded it in infinitely small increments, approaching it, you would get $2.72. That is E. That's where it comes. That's how it's defined. That's one way of explaining it, and that's the concept of E. It's a limit, is all. It's a limit of growth based on the extreme outer limit of how much you can grow something from the start, and how fast it can grow. So now back to Euler's identity: e to the I pi plus 1 equals 0. Now we've explained E. Now we've explained pi, 0, and 1. Now how about I? I is the square root of negative 1. Doesn't exist, but let's pretend it does. No number, a positive number times a positive number is positive, and a negative number times a negative number is positive. So there's no number that is equal, that when squared, because that would mean that I squared equals negative 1. There's no number that when squared gives you a negative number, but we'll call it a number I squared root of negative 1. And what that does is that gives you a coordinate, a number plane as opposed to a number line. X can be the real, and the Y can be the imaginary. And so if I have 3 plus 4i, I would get something like this. This is 1, 2, 3, 1, 2, 3, 4. This could be 3 plus 4i, which could be thought of as a vector. A vector because it has a scale, it has a magnitude and a direction. Or it's called and then you can make a circle out of it. if you take all the vectors that have the same magnitude with center at the origin, you have a circle, all possibilities, and where this radius is, where this length is r, and at any given point, the direction is determined, is defined or measured as an angle, theta, from the x, starting from the x-axis equals 0. So this r, which would be it's called polar coordinates, a radius with a direction or an angle. A radius and an angle is r, and this is the angle theta it makes from the x-axis. Theta is in radians, which means it's the amount of arc you measure if the radius is 1. So if this r is 1, then the theta would be this amount right here. We call that the angle in radians. So let's just say this for simplicity. Let's just say that r is 1. That gives us the unit circle, and you could say that you could say this. You could write this. You could say that if this is 1, then this value here is cosine theta, because cosine is the adjacent divided by the hypotenuse. If the hypotenuse is 1, then the adjacent. If the hypotenuse is 1, then the cosine is just the adjacent, this angle, and that is just the x value, which is just the real value. So the real value is cosine theta. The imaginary value would be if this is 1, would be sine theta, because sine is the opposite over the hypotenuse. If the hypotenuse is 1, then the sine is just the opposite. So this right here is I sine theta, because this is the I-axis, and this is sine theta, I sine theta. So you could say that the number is actually, for the radius to be, if the radius is 1, the number is cosine theta plus I sine theta. That's interesting, but it's kind of obtuse. It's how do you write that easier? Can you make it an easier form, or can you make an equation out of that? Well, they thought of an idea, make it e to the I theta. And it turns out that if you take e to the I theta, it equals cosine theta plus I sine theta. So you can just say that the exponent, the square root of -1 times the angle is equal to the cosine of the angle plus the square root of -1 times the sine of the angle. But before I leap from this to Euler's identity, which is up here, which is what everyone seems to want to do. A lot of people do that. I'm going to not do that yet. I'm going to say, why is this true? Where does this come from? Where does e to the I theta equals cosine theta plus I sine theta come from, and why is it true, and how do we know that? And then I'll worry about how it becomes e to the I, becomes Euler's identity. And then I'll make a funny anecdote about what I think the Euler's identity means, but it's just a joke, but it's kind of funny and cool, I think. Maybe, or maybe it's not, but we'll see. There's something called Taylor series. That's what everybody seems to leave out of the thing, because they either don't know it or think you won't. I do neither. Taylor series says that e to the x equals, I have it right here, so I'm writing it down so I don't mess it up. 1 plus x squared. Can I not write? X squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial. All right, there's some terms. And I also know, we know, or somebody knows, that cosine x equals 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. That's interesting. And then the sign of x equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, etc. They're infinite series, i.e. Taylor series, and they go on and on and on, but that's the breakdown. I know I wrote sloppily, but well, that's just me. Okay, now what if I do this? Let's do a magic trick. Let's make x ix. The x is going to end up being theta, but let's just call it x for now. X is an English letter. Theta is a Greek letter. It's easier to write x for now. Equals ix. I'll plug that into this. And then see if it adds up to any of this. Makes any sense. How about that, guys? Well, so, okay, let's do it. First you have 1. Then you have x. What is x? X is x. We're good. X squared over 2 factorial. 2 factorial is 2. And x squared is... Oh, I get it. I'm goofing. Haha. You're going to say e to the ix. You're going to replace x by ix. So you have 1. Now, I wasn't going to finish that way, but I started to goose, didn't I? 1 plus x, but x is ix now because you replaced x with ix. Now that's 1 plus ix squared divided by 2 factorial, which is 2. What's ix squared? Well, I squared is -1. X squared is x squared. And -1 means I got a minus sign on here. And x squared means I have an x squared right here. Now plus 3 factorial is 6. 3 times 2 times 1. And then x cubed is I cubed, which is I times I is -1 times negative I. So that's minus I x cubed. There you go. I hope I did that right. Wait, I sure hope I'm doing this right. It's plus x cubed over 3 factorial. Okay, it's I squared is -1 times I is negative I. All right, so far so good. I did do it right. Okay, 4 factorial is 4 times, is 24. It's 4 times 3 times 2 times 1. X to the 4th, but you have I. All right, you have I to the 4th. Well, I to the 4th is, I squared is -1. I to the 4th is I squared times I squared, which is -1 times -1, which is 1. So then I have plus x to the 4th, and so on. Assuming I did all that correctly, I had all these were positive. I squared is -1, so I had the negative that, and then I had I cubed. -1 times I is negative I, so I had that, and then the negative, the I to the 4th is -1 times -1. Okay, I think I did that right. Now let's see if that adds up down here to what we have. So let's have cosine x, but let's change that to cosine ix. All right. What is the cosine of ix? All right, let's do it. I got my little note here. Make sure I don't mess it up. You got 1 minus x squared over 2 factorial. Well, minus is there. 2 factorial is 2. And ix squared is negative x squared. Because the x squared is x squared, and the I squared is negative 1. So you get 1 minus, wait a minute, red alert, x squared, ix squared. The I squared is negative 1, but this is it becomes plus. Because the formula says it's minus, but then the x squared, the I makes it, I squared negative 1, makes that into a positive. So there's that, isn't there? Oof. Now here you have a plus. 4 factorial, again, is 24. And what's I x to the 4th? You have the x to the 4th, good enough. But now you have I to the 4th power. But I squared is negative 1. I 4th is I squared times I squared. Negative 1 is positive 1. So you just have that. Simple. I 4th over 24. Now the next term was negative I to the 6 over 6 factorial. 6 factorial is 6 times 5 times 4 would be 24. 5 times 5 is 20. What's 4? 4 times 3 times 2 times 1. 24 times 5 is 96. 96 times 6. 6, 3, 54, 5, 6, 7, 5. I should know this better. 4 factorial is 24. Then 5 factorial is 5. 24 times 5. 0, 2, 120. 120. It's 24 times 5. It's not 24 times 4. It's 120. And that times 6 is 720. So then, just going to do basic math, Jimmy. This becomes 720. Let's write it over here. Your thing was minus x to the 6 over, and then 120. All right, fair. I mean, yeah, I did that. No. 120 is 5 factorial. 5 factorial is 120. 6 factorial is 720. I just did that. I just said that. 0 to 720. Sorry about that. 720. So it's 0 to, yeah, 720. That, I didn't write my 0 good, did I? All right, but that's x to the 6th. Get this basic math erased here. What's x to the 6th? X to the 6th is x squared is negative 1. So x to the 6th is negative 1 times negative 1 times negative 1. Because squared x squared times itself is x to the 4th, times itself again is x to the 3rd. So it's negative 1 times negative 1 times negative 1, but negative 1 times negative 1 is 1, times negative 1 is negative 1. So you just get negative x to the 6th, I think. Wait, no, I don't. The formula says it's got a negative x to the 6th, but when you take x to the 6th, if you take the I involved, that becomes 1. It is negative that, so you get a plus. Changes the sign of it, doesn't it? This is what Euler did to get his name on this formula. This is the math he did, and this is really all he had to do. As boring as this sounds and looks, this is what Euler did to get his name on this formula, and the identity for that matter, which came along with it. What's sine of Ix? All right, we know sine of x. Let's do sine of Ix. Sine of Ix equals. So we're going to my sine page here. First x. All right, well, x is Ix. So let's write that sucker. X is just Ix. Minus x cubed over 3 factorial. All right. 3 factorial is 6. So divided by 6, but x cubed. We'll write this a little more economical spacing-wise. Minus 6. And then x cubed, well, x cubed has got your x cubed, but you have your I cubed. I times I is negative 1 times I, negative I. because I squared is negative 1, and and negative 1 times I is negative I, which is I cubed. All right, then plus x to the 5th over 5 factorial. 5 factorial is 120. I sure hope I'm doing this right, but whatever. 120 is 5 factorial. And above it is x to the 5th. So x to the 5th has got your x to the 5th. But now you multiply that by I to the 5th. X to the 5th. Multiply that by I to the 5th. Well, I to the 5th, I squared is negative 1 times I squared is negative 1 times negative 1, which is 1 times I is I. Yeah, x to the 5th is, I to the 5th is I. Wait, let me think. I to the 5th. I squared is negative 1. I to the 4th is I squared to 1. No, I to the 5th is I. I to the 5th is I. Duh. Because the I squared times the I squared is 1, which is I to the 4th, but then you multiply that by I, and 1 times I is I. All right. Then I have minus I to the 7th over 7 factorial. All right. Minus the 7 factorial. What is 7 factorial? I don't know. It would be, if 5 factorial is 720, which, oh, that was 6 factorial. Yes, 5 factorial is, 4 factorial, 24, 5 factorial is 120, 6 factorial is 720, right? 24, 120, 720, 720 times 7. So 720 times 7, whatever that is. 0, 14, 1, 50, 40, 5,040. So this is going to be, the number down here is 5,040. That's 7 factorial. Above it is minus x to the 7th. So you're going to have an x to the 7th. But we have a minus involved. Put it down here. Minus 5040 over x to the 7th, and then times x, I to the 7th. Well, I to the 6th is minus I times minus I times minus I, which is 1 times minus 1, times I to the 7th is minus I think. I think that's minus I. Oh, but if it's minus I, it becomes a plus, because the formula says minus, so the minus I and the minus I makes it a plus. Is that correct? I always do it. I always do a little trick. I go, I times 1 is I. No. Yeah, I times 1 is I. 2 I times 2 is negative 1. Just go around the circle of the unit circle. I cubed is negative 1. I to the 4th is 1. I to the 5th is I. I to the 6th is minus 1, and I to the 7th is minus I. And if I to the 7th is minus I, and the formula said minus, then you get a plus I. X to the 7th over 520. I did it right. All right. That's what we have. The question is, does this all show that e to the ix is equal to cosine ix plus I sine x? Oh, I know what I did wrong. Cosine theta plus I sine theta. E to the I, it's e to the ix is this. I want to show that's equal to cosine theta plus, I goofed. Cosine, I know what I did this wrong, but I've never done this. So you guys are seeing me do it for the first time. I apologize. I've never done this before. and I see what I did wrong, I can do it right now. So that's e to the I theta right there. E to the ix. We got that much. But is it equal to question mark? That's the hard part. That. Cosine. Okay. Yeah. There you have it. Cosine x is just 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Cosine theta. All right. Sine x is, I'm running out of room on this board here, is x. Let me just make this more economical here. I'm running out of space kind of in here. This is minus x to the 6 over x over 6 factorial. Got it? Sine x. No wonder I had a heart. No wonder I got to name it. It is kind of mind-bending here. Sine x equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th. If I can write x to the 7th over 7 factorial. That's sine x, that's cosine x. But what if I take I times sine of x? So sine of x times I. Cosine theta plus I sine theta should be e to the x. You multiply all this by I now. So this is your cosine theta or cosine x. I want I times sine of x. So what do I get? I'm in dl. I get I times x. I'm multiplying everything times I. Here, I get minus I x cubed. I'm just multiplying everything by I. And here I get I x to the 5th. And here I get I x to the 7th. You see that, guys? So e to the ix equals 1 plus ix minus x squared over 2 over 24. I think. No, it is over 2. That's a typo I just did. That's 2, not 24. Yeah, all right. E to the ix equals 1 plus ix minus x squared over 2 minus ix cubed over 6 plus x to the 4th over 24. And the madness goes on and on and on. Let's see if we added up this correctly to make this equal to cosine x plus I sine x. The cosine x gives you a 1. There's a 1. Voila. The I sine x gives you ix. There's an ix. Whew, we did it. Cosine x gives you a minus x squared over 2 factorial, which is minus x squared over 2. We did it. Next, I sine x gives you minus I x cubed over 3 factorial. Here we have minus I x cubed over 3 factorial, which is 6. We did it. This 3 factorial is itself 6. But this guy must have stayed up a while to do this. Maybe a night. This x, then you have x 4th over 24, x to the 4th over 4 factorial, which is 24. Here, which is 24. Voila, we did it. Looking good. The next term would be of this would then be this guy, not the sky, but this guy. That's Jimi Hendrix lyric. And then the next one would be of the next alternating one would be this guy, and then the back and forth. Sure enough, these all add up. I just proved, even though I'm not the first, or it could be called Weismann's theorem, but I already have named that myself, so I would have to have number 1 and number 2, and that would be silly maybe. I just derived essentially that e to the I theta equals cosine theta plus I sine theta. I derived it. People don't do that. and very often, and I've never seen it done personally, but I've never done it personally, but I just showed it to you guys and did it for the first time myself. So what about the unit circle? If this is a unit circle, if you have 90 degrees, if 9 degrees, but if r is 1, then this arc is pi over 2, because if this arc is 1, this is 2 pi, because pi equals c over d. If d is 2r, and if the d is 2, because r is 1, then the circumference, and then pi equals c over d, then cross multiply, pi equals c over d, then wait, no, if pi equals circumference over diameter, diameter is 2, then let's get the right equation. Then pi equals c over 2, then 2 pi equals c. I mean, gosh, 2 pi equal 2 pi equals c. Yeah, 2 pi equals c. So the whole circumference would be 2 pi. So half a circumference would be pi, and then half of that, or a quarter of a circumference, would be pi over 2. So this angle, which we would sometimes call 90 degrees, is actually pi over 2. That's the angle we're talking about. That's this angle. So then plug this in. I drew that pretty big, but we can do it anyway, I have a feeling. E to the I pi over 2, see that, equals cosine pi over 2 plus I sine pi over 2. E to the I pi over 2 equals cosine pi over 2, but cosine pi over 2 is 0, because the x part of that is 0, so that becomes 0. Then you just get I times the sine of pi over 2. But the sine of pi over 2 is just 1. It's the radius length. So that means that becomes pi over 2. So that becomes e to the I pi over 2 equals cosine I sine pi over equals I, doesn't it? Right? Sounds good to me. The cosine pi over 2 is 0. The I sine pi over 2, the sine pi over 2 is 1, so that becomes I. Oh, I know what problem I'm having here. Let's start that. This is true. I just did something true. E to the I pi over 2. E to the I pi over 2 equals I. That is true. But that's not the right thing for this derivation. This leads to the fact that if e to the I pi over 2 equals I, then I equals e to the I pi over 2. The ith power of that is equal to the ith power of that, but this part is I to the I. This part is I to the I. This part is e to the I pi over 2 to the I, but that becomes equals e to the I squared pi over 2. But I squared is -1, so that becomes I to the I equals e because you have I squared pi over 2. But I squared is -1, so that becomes e to the minus pi over 2. So I to the I equals e to the minus pi over 2. That, therefore, means that I to the I is a real number, because e to the minus pi over 2 is a real number. It can also be written as, this is power over root, so it could be 1 over e to the pi over 2, because the negative makes it 1 over, but this is power over root. So it could be the square root of e to the pi. So I to the I equals 1 over the square root of e to the pi. That is a math equation, but it's not what I was trying for here. I was trying for Euler's identity, which that is not Euler's identity. That's an interesting observation, though. Let's go back and track. Okay, I wanted to do theta equals pi, didn't I? Because if the r is 1, then half the circumference. If r is 1, then pi equals c over d, which d is then 2r, but r is 1, so c over pi equals c over 2. Therefore, c equals 2 pi. So if c equals 2 pi, then half the circumference, or c over 2, is pi. So the angle we call 180 degrees is pi. 180 degrees is pi. I hate to write that, but it's a stupid. 180 degrees is pi. And what's that? Well, this is the x-axis. This is the y axis. 180 degrees is all the way over here, which this is. Let's do it like this. Let's do it technically. Let's go e to the I pi equals, I don't need that, equals cosine pi plus I sine pi. All right, there's that. But I sine pi is 0. There's no y part, so that just gets x'd out. The cosine of pi is -1. Cosine of 0 is 1, but the cosine of pi is -1. So this becomes -1. So you have e to the I pi equals -1. Therefore, e to the I pi plus 1 equals 0. And that's Euler's identity right there. So let's go back. We're virtually done. I'm just going to add a little anecdote. You guys can tell, I think I did this for the first time on two things. First of all, deriving Euler's formula, and second of all, figuring out that, well, I've done that before. That was just a mistake. Doesn't mean I've done it for the, doesn't mean that was the first time. That e to the I pi plus 1 equals 0. Since this is nothing, this is something, this is a circle, pi, this is imaginary I, this is exponent, I can say that it means the exponent of an imaginary circle can be added to something and still be nothing. The exponent of an imaginary circle can be added to something and still be nothing. Jimmy, Rex, Wiseman, Jr. I made that up. Love you guys. Peace, love, and rock and roll.